it turns out the conifers, pines and spruces and hemlocks, but mostly pines and spruces, they need fire to thrive. So often they're going to burn. A lightning strike or drought or something, they're going to burn. I talk about, which is Atlantis in the Sahara. Who would have expected? I mean, what a great place for Poseidon and Zeus to hide Atlantis. Underneath the desert, if it was an aquatic city, you think to look in the desert to find an aquatic city.
Nice Wednesday evening. Rare to see Mike in the multiverse these days. He's been busy. Good afternoon, everyone. Here with Britt. And I would like to introduce our guest for this evening, Dr. Joanne Ballard, PhD geologist, who has presented at the Cosmic Summit as a member of the Comet Research Group. And we are very, very pleased to have her on the show. Welcome to the multiverse, Joanne.
All right. Thank you, Mike. It's great to be here.
Thanks so much. Well, I wanted to start off the show by just asking a bit about your childhood and what inspired you to become a scientist. We're going to talk a lot of science tonight, but take us back to childhood and what inspired you to go down this path.
Well, that is an interesting question since you're making me go back to childhood, because as a child, I wanted to be an artist. So, and I am to some extent, but I thought, well, I can't really make a living off of that. So when I first went to college, I started out in freshman engineering and at Purdue University and started taking courses there. But I felt kind of overwhelmed. Maybe, it's a huge school. There were huge classes, flunk out classes. So I felt like this is not my area to shine. So I switched to the School of Technology and got a degree in industrial illustration technology, which is a little bit of commercial art. And we went down to the machinery room and drew pictures of lathe. We did sketches of the lathe. We did shadow and perspective and that kind of. So then I worked at Philip Morris in their engineering department, which was interesting, but I was looking more for, if I'm going to do art, I would prefer to do, and this was like engineering drawings, it's a good skill to have, but now everybody uses CAD/CAM, and other softwares. So I worked there for several years, and then I got married and started a family. So stayed at home with the kids and homeschooled them. Then much later, I was on the Atlantis Rising Forum way back, and there were discussions about different things pertaining to paleo environments and the delta oxygen 18 and delta oxygen 16, and it's like, what the heck is that? So then I got interested in the woolly mammoth extinction, and so there was different people on there talking about that and how all this kind of happened in the late glacial and the Younger Dryas. So I became fascinated with that. And there was the mammoths, the woolly mammoths. There was an expert in the Netherlands, and he's still there, Sir Dick Mall. And he's done different shows on the Discovery Channel and things like that, where he went to Siberia and they have the ice cave and they were excavating, a carcass out of the permafrost, which I thought was fascinating. So he invited me to come to the Netherlands. And so I went there and he showed me around, and I went to his house and everything and met some Dutch experts over there. So that was the start of me getting interested in the woolly mammoths. And here is this professional scientist that's willing to do outreach and help anybody that's interested in this topic in his field, which is vertebrate paleontology. So that was a great experience. And then when I got the opportunity to go back to school, I went to Indiana University Southeast, which was closest to me in New Albany, and enrolled in the geosciences department, because that's the closest thing you could get to, like, how can I investigate the woolly mammoth extinction and what happened back then and all that. So I had a head start because my coursework at Purdue helped me. So a lot of that transferred. So then it didn't take quite as long to get a bachelor's degree there. So I did that while I was working there as a receptionist. And so then I was able to get a graduate assistantship at the University of Cincinnati. So I left the New Albany area, moved to Cincinnati, and under the tutelage of Tom Lowell, a glaciologist, Dr. Thomas Lowell, I enrolled in a master's degree program there. A master's degree that took 2 years. We took a trip to Iceland because at one point I was helping out in a lecture hall with another professor, and he was talking about glaciers, and he said, "Oh, well, that's Tom Lowell's student over there. She'll know all about glaciers." And I thought, I have never set foot in a glacier, so I feel kind of stupid, So whenever he planned a field trip to Iceland, I thought, I need to go so I can learn firsthand how glaciers work and what's going on with them. So we spent 2 weeks in Iceland and did all kinds of field work, and it was really interesting. So once I left there, I ended up working at the Census Bureau. So I came back to the area where I live now, and I got a job at the Census Bureau as a cartographic technician, working on an addressing campaign for the Census Bureau on their decennials. Every 10 years, we count everybody. And that turned out to be a very interesting job, although kind of boom and bust. They hire a lot of people, and then once that assignment is finished with, well, then you all get laid off. But nevertheless, it was a very interesting experience. And then later I went to University of Tennessee with Sally Horn as my advisor, and did a PhD. The advertisement was she needed a research assistant. And, oh, by the way, you're going to be getting your PhD while you're here. And so that's what I did, right? And so while I was there, she kind of had it laid out what she wanted done, which was paleoenvironments work where I'm going to quantify charcoal on cores that she already had in-house that a previous researcher, Hazel Delfcourt, had done the polymer. So now I'm going to add the charcoal data to this. So that was the plan. And so there was a lot of fairly straightforward, as well as geochemical data. We were going to put that with it as well. So I got the data, and, being kind of a technical person, I wrote it up as a report. And by the time it got done, it was like 200 some odd pages. And it was supposed to be a proposal. Well, I've already done this work, so I might as well tell where I am. And Sally's like, Joanne, this is not a proposal. This is way too long. Here's a template, redo it. So then as time went on, sometimes she would be busy and I would add notes and that. Before you know it, it's 200 pages again. So here's the next edition. She's like, no, it has to be, less. It has to be 25 pages. Okay, well, I had a 25-page one, but then I added to it. So eventually I did get done with the third version, with all this data from 6 different lake sediment sites. So what we were doing is taking lake sediment cores, and the deeper you go, the older you are in time, and you're going to analyze for different things. And the core is about 2 inches in diameter, and you take a meter at a time, and you just keep going deeper and deeper until, you're typically that it's the bottom of the pond or the lake, or that's as far as you're going to go. But typically we get to the bottom. But when so in the Southeast, those ponds are sinkhole ponds. And in Michigan, which is where I cored lakes for the Cincinnati research, those are kettle lakes up there, where it was close to the ice sheet, the Laurentine ice sheet, and chunks would fall off and get buried in the mud. And then eventually, when that ice finally melted, then you had a pond. So that's a little different situation.
And that's different from a sinkhole pond, which is where you're describing really underground erosion where water can wash away sort of carbonate type of stuff. Is that right? Versus what starts a kettle pond then?
Well, a sinkhole pond is it's in a karst terrain, which is limestone. So over time, there's cracks in the limestone and then it dissolves, with the CO2 that's in the rainwater. Eventually it dissolves and, underground, you might have caves in that form. And so if that sinkhole pond gets plugged, well, then you can have a pond and the sediments start to accumulate. And that's what we as researchers want. And so we take sediments from ponds rather than just the soil up on a hill or something, because there could be worms, there could be tree roots that would disturb the soil. Whereas if researchers consider that typically ponds and lakes are not as disturbed. Mm-hmm. So that's why they go to those repositories to try and get information on what happened in the past using proxies, which means we can't be there to measure the temperature. So maybe we're going to look at the gnat's head capsules, and we know that this type likes that kind of environment, and this one likes warmer temperatures, and so on.
And that, of course, is the biggest challenge to understanding the past. In science, it's all about being able to repeat your experiment, have someone else reproduce the results. We can't all go back in time and try to see what happened. The best we can do is take more measurements and try to discern with those measurements of what was going on. I wanted to rewind a little bit because I remembered in one of your presentations, you described going out to get the lake sediment cores. You said it was a team of researchers and volunteers. You had mentioned before you even started the master's degree about a trip to the Netherlands or being involved in the Netherlands. So were you that volunteer for someone else's research endeavor at first?
No, that was my own. I initiated that, and I coordinated with researchers over there, such as Bas van Heel and Jan Sevink. And since they know that area and they're experts in the field of paleoenvironments, and Bas van Heel is also a palynologist, so he looks at pollen and botanical macrofossils and so forth. And so I checked with them and I said, do you know of any sites where I could look at the black mass Oslo horizon and take samples so that I can look at them? And this came about because Han Klosterman, who was a Dutch researcher that was an expert on the black mats and was part of the Comet Research Group, and he was a co-author on that initial paper with Rick Firestone and Alan West, co-authors. He had sent me samples from the Ossendrecht site, and these are, so what the Oslo horizon is, they have cover sands over there, and in some places you can look at a profile, where you have an exposed surface of the cover sands, and there's a black layer, and that black layer has charcoal, soot, sometimes like twigs and burned wood, and typically fused quartz, melt glass, all this indication of a thermal pulse. And so I had analyzed samples for that horizon that Han had sent me, and there was a ton of soot. There was wood that had a coating of silica, that had melted, and it looked like fresh wood, and all kinds of things like that. I had a thin section made to look at the sand, and so you can have a thin section made where epoxy with it, and then take a paper thin slice of that, and then you can look at that under the microscope and examine the grains in cross section, and use cross-polar lens, cross-polarized light and all that, plane polar light, and so I was seeing some pretty strange things, and so I actually wrote to Christian Coburl and, hey, what do you think about this? Could this be a microspheral like Alan West and Rick Firestone have been talking about? Look at these strange structures. So his view was, fused quartz and things like that could have been transported down the river and just deposited, and they were detrital grains. And so he kind of was dismissive of it. And I thought, well, this is one site, so I don't know. So then I came up with the plan to, like, why don't I go back and sample from different sites at different geographic locations, and then we'll compare and we'll see what we find. So that's when I got with Vas van Halen, Jan Sevink, and others over there, Case Cassie, I think. And so we took samples from a site near Amsterdam that Vas van Halen, Jan Sevink had worked on. So I got samples from there. And then, so that was around Amsterdam. Then we traveled to the east side of Holland and went to Luterzand and took samples from there. And then we traveled to the south and we collected samples from Belgium and from Lommel, Belgium. And so now I had 3 additional sets of samples to look at. So then I came back and used the microscope at University of Cincinnati. Warren Huff had a very sophisticated microscope there that with very high magnification. And you can see images of. No, it was just a regular microscope, light microscope, but it went up to like 1,000 power, and you could take pictures. So it was a little tricky because you had to, at that resolution, at that magnification, you had to stack your images so that you had a clear enough view of the sand grain, because otherwise, had the depth of field problem. So anyway, I collected images from that. And so there were interesting, so this is the actual loose sand grains I'm looking at to kind of assess what's there. And there were a lot of sponge spicules, as well as charcoal, as well as sand grains that were had a coating of mud on them, because I did a scanning electron microscope analysis of one of those, because it's like, what is that? It looks kind of like a pattern. And it actually was 3D once you looked at it with the 3D, with the scanning electron microscope. It was 3-dimensional, like it was a mud crust or something on there. So there's, when you look at the Oslo horizon in the field, there's the yellow sand grains, that's iron oxide coatings. And then below that, you've got like the charcoal layer where all the action happens. And this is the Balling Aileron to Younger Dryas transition boundary.
Yes.
And below that, typically the sand light colored, like it's bleached or something. So most of those Dutch scientists over there consider it a soil. But to me, it's like, it's kind of obvious it's an event horizon. Can't you see that? But Vas van Halen wrote a paper, I think it was in 2000 maybe, that said, oh, well, we don't need a comet impact to explain this burn layer, which, by the way, is pretty widespread across Europe. And it's called the Finno soil in Germany and Poland, and the Oslo horizon in the Netherlands and Belgium. So there's this widespread layer that is dates to around that time. Although Han Klosterman told me there was more than one of them. Like, was there another event some other time, later, maybe end Younger Dryas or something. So anyway, there's, to me, that looks like an event horizon, but they want to interpret it as a soil. They call it a soil. And I think the light color underneath may be due to acid rain. Because if you have an extraterrestrial impact, that's going to, you have that shock wave to the atmosphere. It dissociates the nitrogen. The nitrogen forms nitrates. That rains out as nitric acid rain. That's a known thing associated with an extraterrestrial impact. So that's what I think is, it will explain, why it's pale underneath these burn layers, the Oslo horizons. So,
and is it also
so just anyway,
I was going to ask, is it also just underneath that layer because at that time the burn layer has formed and it's thin enough that the acid rain sort of soaks down and can be underneath, because otherwise underneath would be before the burn? Or am I understanding that right?
Right. Right. So I'm interpreting that as the acid rain soaks down through, and that may not be correct. That's one hypothesis. And there is a paper out there that I saw not too long ago where they were saying that the Oslo horizon was impermeable. So I have to go back and revisit that and compare that to that idea that I have of the nitric acid rain. However, there was a place where typically you just have this. You typically have it just the burn layer with different things. Sometimes it looks like peat. So when we went to Luttersand, it looked like there was a bit of peat in that layer as well as charcoal. But there was a place at Lommel where there was a trench dug, and we went further down and dug a new hole, and there was laminations. The burn that brown was in laminations of like 22 thin, very thin layers, and there's sponge spicules in there. So is that the sponges building up one layer and then another, and then they die off, and but it almost looked to me like nutrient pulses, because nitric acid rain can serve as a pulse of nutrients, and you could get algae overgrowth and that kind of thing. So to me it looked like and as time goes on, there'll be less and less nitric acid rain washing out of the atmosphere. Eventually things will return to relative, but at the beginning it's going to be more concentrated. And then that stack of layers, which you can see in the PowerPoint in ResearchGate, I've got a picture of it. It's like a deep brown color at the bottom, and then it gets lighter and lighter. And to me, it looks like the nutrients are raining out. The nitric acid rain is raining out, and that's why it's getting lighter as you go up in that stack of laminations.
Well, that makes sense. And to their point about being, well, it's a layer of a certain type of soil, there still needed to be an event or a series of events that transpired that made that layer of soil different, physically different from the layers of soil surrounding it, whether it was one trigger event followed by a couple of 100 years of altered equilibrium. That to me, that constitutes a different layer of soil. So perhaps there's a subtle agreement there, but I get what they were trying to say was you don't have to invoke an airburst. You don't have to invoke an impact. So 6 one way, half a dozen.
Right. So what he said, well, you can have, he said, you can have a drought. You can have a drought. And then there was people there, and people can start fires. And of course they would be, Paleo Indians and, whoever was the Aboriginal people at that time, they would definitely be using fire. So he's saying if there was a drought, you could have this burn layer. But to me, it's such a ubiquitous layer over such a large region. It's like, what is the likelihood that you would have that? It would preserve, to me, it looks like an event.
Yes.
So I think the event makes more sense. I mean, he's got a good point, but yet I think it's over too large of a region for that to be the case. But
I would agree. And certainly an event followed by a brief period with altered equilibrium far out from normal, that would constitute, to me, that's good. Neat.
Well, and we don't know about a second horizon. Hans Klosterman mentioned that, but most of the time you just see the one, but but they have the characteristic of soot, charcoal, meltglass, fused quartz, sponge spicules, and sometimes bright green vegetation could be in there with it. It could be preserved by the silica melt or something, but it's quite interesting.
And that does make a good case for a rapid event. How else would the bright green plant be preserved in that state to be detected later on?
Well, if you have an anoxic condition, maybe you can pull that off. So, and I have seen bright green leaves at the bottom of lake mud in Michigan. It's like, you would think this would decompose, but if there's no oxygen, maybe it doesn't deteriorate, and that could explain its preservation.
Well, thank you for the synopsis of that research. So taking lake bed sediments, which are better preserved than the surrounding lands, stuff lands in the lake, settles to the bottom of the lake, and stays there, hopefully untouched unless the lake dries out. getting those scores and analyzing them, matching that up with the chronological dating. And look, there we have proxy evidence for impact around the Younger Dryas time period. Thank you, Joanne. I wanted to ask you a question just from reading your ResearchGate overview about some of your work with Tennessee Valley Authority. Is it all right if I ask about that a little bit?
You can. So that basically was, they actually had a group of archaeologists that worked for them. And it's like, oh, I thought they, managed the waterways and the dams and, you had hydroelectric and that kind of thing. And, but they had an archaeology department and they had to keep track of where all the archaeological sites were along the rivers, which there's a huge number of them. But they would number the sites according to the Smithsonian's trinomial convention. So you might have a site that would be, there would be like a number for the state. So let's say 20 is Tennessee. I forget right now what it is. So let's say 20 is Tennessee. Well, then you have 2 letters for the county. So KN for Knox County. And then you would have a 4-letter, 4-number number for the site name. So 20 KN 1234. Mm-hmm. And so all this data had been dumped into this database and it had to be whatever you put in there. So people would write a report about, say, 20 KN 1234, and they write it up and say, well, we think it's this particular, it's an archaic site. We found this, that, and the other. And, so in the attribute, it was linked to a map. And so in the attribute table, you needed to reference like the author of the report and different things, the latitude and longitude and different things that you could capture in the attribute table, but you also linked it to a database that could be queried and you could pull up the information that way. So that was a fairly, it was database work with mapping involved, and I liked it. Some people might think it's a little dull to sit there and input data and format data and clean up data, but I thought it was interesting. It was a very nice company to work for, and they do good work, TVA. Some people don't like TVA because they use eminent domain in order to set all this up. So some of those dams, there is property that is under the water, that maybe have been in their families for a long time. And so some people have hard feelings about that, historically. But it really helped provide economically feasible electric to have that hydroelectric power.
Yes.
So,
I appreciate that. I wanted to ask about that because I actually took an introductory GIS class this past spring. And during that same time, at some point in February, maybe we did an interview with Dr. Greg Little, who is the expert in the United States on native mounds, native mound culture across many, many states. And in that class, I went into whatever databases we had access to, and I tried to look up, native mound sites, native burial sites, find some. I couldn't find anything that was exhaustive. I found it looked like a few people had a side project where they tried to upload some data and just thought, gee, if I could clone myself, I would send a copy of myself up to Dr. Greg Little and try to get all this encyclopedia into a GIS database. And I agree with your point that it's kind of repetitive work. It can get a little bit robotic when you're entering things, but it's still a technical skill. And we know as scientists that there is a lot of grunt work that goes in. It's not glorious. It's not really glamorous, but we get the credit, hopefully, with the end product. Yeah. So I think it would be a very, very good spend of time for some folks to help Dr. Greg Little. Yeah.
So counting on a Petri dish, that's fairly tedious work, but you can put music, it's very rewarding to see the graph when you get done of where are the high points, and there are high points at the beginning of the Younger Dryas in, say, the Michigan lakes, but also earlier. Yeah. So it's okay, well, so Tom had said to me, before you do the research, come up with some predictive hypotheses on what you think you might find. So, so I'm going to think, maybe I won't find any charcoal peak, so that would be maybe the null hypothesis. Then I could say, I'm going to find a huge spike of charcoal at the Younger Dryas. or maybe I'm going to find multiple peaks. So what will I find? So then I get into it, and I did find probably the biggest spike was at the onset of the Younger Dryas in some of those Michigan lakes, and we cored 4 different lakes. But there were some early. So then it's like, well, did you have like multiple terrestrial hits, or that's something else going on? So what I learned through my work with Sally Korn, more on the biogeography of what's there and what's burning, it turns out the conifers, pines and spruces and hemlocks, but mostly pines and spruces, they need fire to thrive. So often they're going to burn. A lightning strike or drought or something, they're going to burn. They have those terpenes in them, those oils that make them flammable. And they need that trash that's the duff layer, they call it, underneath the pine trees. That has to be removed before the seedlings could sprout. So a fire will take care of that. And then the cones will open up with the heat. The serotinous cones will open up, and now the seeds are released, and there's the soil is exposed, and they can sprout. So pines have evolved with fire, and so it's normal to have like fires with pine forests like we see in the boreal forest today in Canada. So it's like, okay, so then how would I differentiate just a regular pine forest burning from something really much bigger? So then you have to look for other proxies to go with it. Is there something that distinguishes this charcoal spike from the others that will make it stand out? And you also compare your research that you've got a chronology to with your radiocarbon dates to what's in the ice core record or other, Marine Corps records and so forth. So Petiev et al. In 2013 wrote a paper where they found platinum in the Greenland ice cores at the beginning of the Younger Dryas. And they said, we think this is a global signal. Okay, so there's your platinum. So where are you going to get platinum from? An extraterrestrial impact, or it could be a volcanic eruption. So you have to be careful when you're interpreting that you take into account, what are the possibilities of where this came from. So I don't think they have found a volcano that matches that could have erupted, maybe Iceland, but they haven't found anything like that. So I think those two options are there. And also, I think the work of Charlotte Green, she's been trying to determine if the platinum came from a volcanic origin or an extraterrestrial, but I don't know what she has figured out yet, but she was working on that. So there you have that platinum spike, and then you also have the black mats of the Southwest where they're finding I think it's magnetite and the spherules, and and you also have, from my work in the Netherlands and Belgium, that appears to be a thermal pulse. Because of the melt glass and the fuse, that's another reason I think it's human caused, because the intensity of the heat in order to melt the sand grains, the quartz grains, and fuse them together, or even create melt glass. So those are that kind of encourages me to think that, yes, I do think this is extraterrestrial in nature rather than volcanic or people starting fires and that kind of thing.
That makes sense. Can you tell us about getting the cores from the lakes? So you're going out on the frozen lakes. You talked about this in one of your presentations, maybe had a picture. What is the experience like going out on the lake? It's frozen. How do you get it back safely?
Right. So in Michigan, you can go out in a frozen lake, and this is advantageous because it's flat, it's level, and if it's 6 inches thick of ice, you can even drive a vehicle out on there. But we took sleds, so we have plastic sleds, loaded all the equipment, and took it out there. And so of the 4 lakes that we cored, one was like at a state park, one was at a county park, and 2 were on private land. And so Don Simons, a local archaeologist, he helped us get access to those 2 private lakes, which is excellent because nobody else had data on those lakes. And so they had not been bothered or anything. And Slack Lake was quite large, so and Swift Lake was smaller. So Slack and Swift, the key thing about those is when the paper came out, Rick Firestone's paper had just come out in 2007. Here I am at University of Cincinnati in 2008. And it's like, well, if we're going to test their hypothesis, we should go near the Gainey site in Michigan. So those two lakes were the closest lakes to the Gainey site, where Don Simons had found all these arrowheads and stone tools and so forth. And it's like, well, we know people were there. And so why don't we go there and core those lakes? So that was the point of doing that. And so I think we started at Slack Lake, and because they're on private land, it was not the easiest to get to. So we had to park up near the person's house and then go down a big hill with all our equipment. And we used a Livingston coring device. So we all had to pull those sleds out, and you take an auger and you make a hole. You're trying to figure out where is the deepest part of the lake. And so for some of the public lakes, you can access bathymetric maps of all those. And so that's helpful. But for these two, I'm not sure they had that. But anyway, we augered some holes and figured out where we wanted to core. Then we set up the Livingston corer, which is a 2-inch diameter, and it had pneumatic assist. The one that Tom Lowell has pneumatic assist, which helps pull it back up.
Yep.
So you're going to put your coring device down into the mud, and we don't care about the lake Holocene. We were interested in the lake glacial. Yep. So we went down until we hit like sand and gravel. You keep going. So you go through the squishy stuff, and then you start collecting the cores. And when you push them out of that tube, you have to make sure that it's on this little platform you've got made of lake sand or plexiglass that sits up about 2 inches, and you put down saran wrap, and you extrude out mud, and you better make sure that you know which end is down and which end is up, or you're going to have a real mess when you get back to the lab. So whatever the coring device, it's pointing away. So whatever's pointing away is down, because it came up out of the lake and then onto that little platform. So the person wraps up that the saran wrap in the mud, and then you have like PVC pipe, which has been cut to meter length and then split lengthwise. So now you have two half shells of the PVC pipe, and you put your sausage of mud that's been wrapped up real nice in the saran wrap, and then you put the lid on it and you tape it up. And then you label it Slack Lake, and whatever depth, which Tom Lowell would know how many rods he put down, how deep we are, you would tell, let's say it's 1,200 to 1,300 meters below the ice platform. You also have to figure the depth of the water and all that.
Of course.
And then you set that aside, and then you go down another meter and you get another one. Mm-hmm. And then you label that. This is 1,300 to 1,400 centimeter depth. I may have said meter before, but centimeters. And you continue until you hit resistance, which would be the sand or the gravel at the bottom of that kettle lake. Yeah. And then typically we offset maybe a meter away. We auger another hole, and we go back down in, and we get another set of cores that's offset by half meter. That way, where the break in the core is, you typically lose some of that material. So now if you get a second set, you'll still be able to get all the data all the way down.
Yeah.
So there's your two sets of core, if everything goes well, which it did not at Swift Lake, which was the next one. So we got our cores at Slack Lake. That's great. And so in the afternoon, we went to Swift Lake, but something went wrong with the equipment. And so we had issues. We had to leave and go to Home Depot or something and get parts and come back. And so that one we had confusion on. We went back at the same depth, I think. And so once we got back to the lab, it's like, okay, you're looking at the data, and, because we went back in the same hole, I think the sediment was kind of disturbed, and we had to sort that out.
That's exactly what I was about to bring up. So the first thought that I had when you were describing that process is you better get the drill back down there quick because, yeah, it's frozen. But if you wait too long, things are going to start to squeeze in and you'll be influencing that very next layer. Now, if you can pull it out, label it, and go right back in when we're frozen, I don't think you have to worry. But if you had to get off the lake and go to Home Depot, I think the data would be off.
No, actually, the mud's not frozen.
No. Okay.
The mud's not frozen because it's just the top layer. You've got that platform of mud. Then underneath that, you've got the water column. So maybe the water column is, 10 meters deep. And then you've got the mud water interface, and that's what you're going to go down into. So it's not frozen. So you don't have to worry about that.
In that case,
we had a kind of a channel or something to help guide so that you would try and get back in the same hole so you could go deeper. And, but you also had a rod to measure. You'd add a rod if you want to go a meter deeper, and then you put that back down, hopefully in the same hole. But, so that's how it's done. So no, you don't have to worry about the freezing, but then it's like you've lost track. You've got rhythm when you're in the field of what you're doing. And now we had to stop everything and go do that, come back, and okay, where were we? And that kind of thing. And start over.
I know the feeling.
So going back to your...
Sorry, yes, go ahead.
Mm-hmm. Well, I was just to your mound builder thing and Greg Little. And so was he trying to do a map of mounds? Someone's probably done that, right?
He's got an encyclopedia
with GIS. You were trying.
As far as I know,
but
he's
not
got
a GIS.
Yes, not GIS. That's right, non-electronic.
So that's where you were going to try and that as a project, maybe.
Sorry to bounce around, but I'm following with the ice cores, and you're right. That was foolish of me to think that the water is obviously liquid once you punch through the top of the lake.
Well, if you haven't done it, it's all like quite an experience to figure out like these important things, like which end is up, and it's like, oh, if this was my first time and I had like a novice with me, I would like be on them about, and then you better label that little platform which end is up so that if you're looking doing something else, that person has a guideline to kind of minimize it, because it's a lot of work and expense to be out in the field. So you want to try and minimize the errors that can happen.
Yes. So we've got a set of sediment samples from the lake beds, and we're taking them back. We've got them back to the lab, and we kept them all upright. How do you start finding the point? Hopefully the two cores match. Yeah.
All right. So no, they're not upright. They're laying horizontal, and we loaded them in the truck.
Yep.
Probably in boxes or something, because they're fairly thick. They're not squishy. Once you get down below a meter of mud, it's not squishy. If you want to do historical analysis of events or something, and you want the more recent mud method, like a Bolivian core or something, or a freeze thaw kind of a freeze collection where you use liquid nitrogen to try and collect it intact, because otherwise you'd have a hard time keeping all that relative. So anyway, we are consolidated sediment, so it's okay to lay that sideways. It's not going to move around or anything. So they transport all of these PVC pipes with them in them back to the lab, get them in order, like, okay, depth wise, off, and you're looking, and you split them lengthwise. You split the mud core lengthwise, and so now you have two, and one of them you're going to archive, and one of them you're going to sample. And so you're going to do that for each of them. So then you get your second parallel core, and you're also going to split them, and you're going to look for features that you can match up. So maybe there's this light lamination in this particular depth that you'll be able to match up, when you're comparing the two sets of cores. You can say, oh yeah, that goes with that. And, there'll be other features typically, and so I think at Swift Lake there was some floating varves. So varves, if you can get a lake with varves, that's great because that's an annual winter summer layer. And then you could also count, as well as getting a radiocarbon date, you could also count the years, and then that would help you have reassurance that your radiocarbon date was good. So, but they weren't continuous varves, so that didn't help. But nevertheless, it was a feature that you could look at, and you might see it in both sets of cores, and that helps guide you to matching things up. Mm-hmm. So that's what we do. And then you're going to put those back in the cooler. You keep them in the cooler to preserve them, and so they don't dry out and everything. And then when you're working on them, you take out your half that you're going to work on. And so let's say I'm going to work on a meter, and I'm going to do charcoal analysis. For that, I used two different analyses. At the beginning, I was not really sure what I was doing. So I would take 4 centimeter long strips, put that in a beaker with some peroxide. Well, now I know that represents probably a couple of 100 years. So that's not an ideal way to do it, but that was a way to start out and learn. And so you would put that with the hydrogen peroxide, put that in the oven so that to accelerate the reaction of bubbling and everything. And then you would rinse it through the sieve, and 125 micron sieve is what I used. And then hopefully you're going to be able to count the charcoal. There's many things that look like charcoal. You might have little black grains that are minerals. You might have insect parts. You might have organic parts. You could have pyrite or greigite, different things. So you would use a probe when you're checking. You'd use a metal probe to kind of like, that looks like charcoal. And then you touch it. And if it's hard as a rock and you can't crunch it, it's not. And then charcoal has a certain luster, that helps you in some cases. In other cases, it's just more opaque. Like it's a burned piece of grass or something, that might be a little different. So then later I went to Kathy Whitlock's lab to kind of vet my process of my methodology. Like, okay, what does she do? And so, because Tom Lowell's a glaciologist, he's not, a charcoal expert. He's a sedimentologist. So this was also new for him. So he said, well, you could go spend a week with Kathy Whitlock and see how she does it. Well, she used household bleach. So she would take 2 cc's at one depth, so a centimeter. She'd take 2 cc's, put that in a beaker with 50 milliliters of household bleach, 50 milliliters of this sudsing agent called sodium hexametaphosphate, leave that sit for 24 hours, and then rinse it through the sieve. So it was interesting to do those two processes because the bleach pretty much dissolves anything organic. And even fish vertebra, you'd see a part of a fish vertebra, and it's like, so it was much easier to count the charcoal. However, in the other method with the hydrogen peroxide, I was seeing all kinds of interesting things like Daphnia, the water flea. We'd see the egg cases. I would see mites and different things that you wouldn't get to see using the bleach method. But I guess that could be considered a distraction. But those would be other clues that could help you, like, do interpretations as you learn more about the other creatures. And instead of just charcoal, you're looking at a multi-proxy approach if you know enough about those things. And I would often reach out to experts like Eric Grimm. I asked Eric Grimm for help on some of the interpretations. Like, do you know what this is, this weird thing? And I'm seeing a lot of them. And he said, that's Daphnia, the water flea, their egg cases. So it's like, okay. So, that must tell us something about the environment, but at that time I was mostly focused on the charcoal and getting that information.
You were focused on that
data. You
did not limit yourself to the people that were immediately within arm's reach. You were reaching out to people that were experts in that. So you were far reaching in spite of that.
Right. Because I was curious. It's like, I have a feeling this could be a clue and it could help us, but still I have to, Tom Lowell's like, Joanne, focus, but still it's like, how does a water flea live, and what are they, what do they need to be happy, and that could like help us interpret more about, so I got that opportunity when I went to Sally's lab because she's a palynologist and a charcoal person. She was more about what are those other things we're seeing, in the sample, and also the data from Hazel Delcourt. She not only looked at the pollen, she was also looking at macrofossils. Maybe she found she found pine needles, and she found other things, seeds and whatnot, and she would report those in with her pollen diagrams.
Mm-hmm.
Okay, so we were talking about
Yes.
the sampling, the sampling techniques and whatnot. So,
okay, so the 2 samples, 1 meter apart. Hopefully those match. If they don't match up reasonably well, then there was some tumultuous things going on in that lake. But let's say that the 2 samples do match. How do we go about finding at which point in these 2 samples does that match up with the ice, like the Greenland ice core? How do we match the lake sediment up to the larger paleoclimate record? That was the next step.
So that's where you have to find something to radiocarbon date. And so in a lake, maybe you can find, if you're lucky, you can find a leaf. If, there was a lot of Daphnia, the water flea egg cases, well, okay, if I accumulate enough of those, maybe I have enough mass to get a radiocarbon date. However, that is an aquatic creature. And so they're getting their CO2 from the water. And so that could include limestone that's dissolved in the water, and then you'd get a falsely old date. So we would prefer to have something that is terrestrial. And for instance, I found a cottonwood leaf in one of the cores. And so that was perfect because that's a terrestrial, that's a tree, and, but oftentimes you don't get that. So in a worst case scenario, I think it was Lake 16, which was the county lake in Michigan that we went to. There was something really good I found to radiocarbon date, and I sent it to get the date. And starting out, you try and get something to date that's a little higher up and something that's lower. So now you have a span of time and you can interpolate, and it won't be perfect, but it gives you a span of time between those 2 points. So for one of those upper or lower points, I have found something in Lake 16 that was like really exciting. Maybe it was a leaf or something. Send it off to the radiocarbon lab, and they wrote back and said, "Oh, sorry, because they combust whatever it is, and they capture the CO2 and they measure it somehow." And so they said, "Oh, sorry, the glass broke and the CO2 was lost to the atmosphere. So too bad you don't get the radiocarbon date because there was an accident." So it's like, my gosh, it's not, it's hard to find a terrestrial, something terrestrial to radiocarbon date. So if there's nothing else there, you do a bulk date. And people, some scientists kind of look down their noses at bulk dates, but it depends on what is the level of calcium carbonate in the lake. And we do a loss on ignition test to gather that data. How much or what percent is organic? What percent is limestone or calcium carbonate? What percent is everything else, silica and whatnot? So we can have some idea.
When you say bulk, how far are we going? Like bulk, the entire meter, multiple meters? Like how far?
No, bulk just means you don't have a leaf, you don't have a twig, you're just taking the sediment. So maybe you're going to take a 1 cc, just the sediment, and that's what we're going to analyze for the organics that might be within that. But you also could be getting the calcium carbonate. So sometimes you might be 1,000 years off, but it gives you some idea. So it's not ideal, but nothing. So that's once you get those dates, now you can compare that. That's how we would know if we, let's say we have the leaf and we get a date of 12,800 for the leaf. Well, then we can say at that point or close to that point, that's going to match up with that platinum spike in the Greenland ice core that Petiev found.
Yes.
So it's the rates, how you link to other records. So in the Greenland ice cores, those are VARs. And so they actually count those and they figure they're not off by that much. Maybe they're off by 25 years over thousands of years. So they're
Really
pretty
good.
confident that there's not that big of an error rate with that.
That makes sense. Well, I appreciate that because it highlights some of the challenges in paleo dating, getting local samples. We think going back 10,000 years, yeah, that's a lot, but you need to match the 10,000 year record to the 100,000 year record, if at all possible. It's not a simple task.
Right. Right. And some of those lakes in Michigan went back to maybe 16,000 kettle lakes. We got dates that went back as, about 16.
Mhm.
So that means that kettle lake was exposed and forming, and the Laurentide ice sheet had withdrew from that area, which was close to Flint, Michigan, around 16,000 years ago.
That makes sense. Very cool. Well, thank you. We're coming up on the hour mark, so we've got a few questions left. We couldn't end the interview without a little bit of discussion on Atlantis. Of course, Atlantis was the big topic at Cosmic Summit. There was the panel.
Right.
What's the latest on your Atlantis endeavors?
Okay, so Atlantis, and that was that field trip was organized by Holden Zhang at the University of Tulsa, and he's a petroleum engineer. But he also, is a side interest. He's very interested in the Green Sahara, and he's got that book, The Green Sahara Now. And we know that the Sahara used to be green some 5,000 to maybe 13,000 years ago. It was the African humid period. And, it's quite remarkable that, it was green and now it's a desert. I mean, it's just absolute desert. So it was quite an interesting experience to go there. So we had drilled down about 25 feet using these concrete collars that were about 5 feet high and 10 feet by 10 feet. And you would set them on the sand and they would dig out with a backhoe. And then the thing would sink down in the sand. And then they put another one on top, and to hold the sand back as you're trying to get down there and dig. This is the method they used. So there is a map online where you can look at the depth of the sand, how high it is above sea level. And I can send that to you if you want. So in the area that we went to, which is Nefta and Tuzur, those two towns are close to where we were with our field site. We were at a date palm plantation doing this dig. And the sand there is about 66 or so feet above sea level. So if Atlantis is there, it has to, the artifacts of it have to be down there 60 some feet below where we were. 25 feet, well, that's not far enough necessarily, unless they had something, sting up. Mm-hmm. And they could, but so we found like an artifact of a toe bone of like an antelope or a sheep or something, and that's about all we found because enough. And so Holden plans to go back. That he go a little. I mean, if Atlantis is a huge metropolis, why don't you go a little further to the northwest where you're already below sea level and set up a dig there? And then maybe it will be less effort to get through all that sand. And that sand moves around incredibly. I think over in Morocco, the sand dunes can be 200 feet high. And they have signs on the road there in Tunisia warning you that, sable, which is the sand dunes, can move across the road if it's that, since the last time, and you could like hit that with your car and roll over or something. So at the moment, Holden plans to go back, but, I presented a lot of different evidence on why Atlantis could be there. And one of them was the Klokochnik's work, the Czeszkiewicz. He had taken satellite data, and there looks like something, he was investigating what looks like it could be the Ferris plain of Plato to the south of where we were. And it looks like there's particular channels in there like the irrigation channels. If you go to Plato and look at that distance and compare that with latitude and longitude, you can get the distance. And it's close to what Plato says. So it's like, is that a coincidence or is there something there? So we had hoped to ground truth that and see what's underneath the sand. And so Gunter Kletechka and Marian Takak, his student, came and they wanted to use drones to get more data closer to the surface, but drones are not allowed in Tunisia. So they were not able to do that. So they collected some other data with kind of a lawnmower type thing, a push device, but we were kind of the drone data collecting.
That's unfortunate. And here on the show, I can't advocate for standing close to the border of Tunisia and flying drones over the border. We're not going to advocate for that on the shows. But
right, and this was not that far. Yeah, it was not that far from the border with Algeria, actually. So maybe that's why, but I think in general, you just couldn't bring a drone into the country and fly it any place. Probably because what's going on in Israel and Palestine, probably the reason they weaponized the drones. So there's many reasons, including the fact that in history, Greek history, they talk about Athena being the daughter of Poseidon. So Poseidon founded Atlantis, and he had 5 sets of twin boys with wife, and then apparently later he had Athena, and her birthplace is Lake Tritonis, which is in Libya. And Libya back then was all of Africa. They weren't sure how big Libya was. So Lake Tritonis was in Libya, which actually could be, the Chott Jared where we were, that could be Lake Tritonis. I'm not sure, or, but she is linked to Africa. And, even though we think of Athena, or if it's Roman mythology, it would be Minerva, we think of that as Greek and Roman, but maybe also it's linked to the Egyptian history and the history of Africa. So, it's really interesting how all of this is kind of tied together. You think, oh, that's Roman and Greek. Well, then you get into the Egyptian and you see some overlap. And so maybe they had different names for the same gods and deities. And so.
Well, and let's not even think that learning mythology is too far from getting samples from lake sediment samples and carbon dating them, because we don't have to go very far back to be in the exact time period that these authors were writing things. So we all just need to reach out and we can start connecting these things. So we're excited to stay tuned for updates. Yep.
Right. So yes, we hope to make more progress with this, but it takes time, and that's kind of a one avenue of research that Holden does, and then he has other collaborators that come in and help him, and like Gunter, Marian, and I met up with him and traveled to the Sahara with him and looked at the cores that he had taken, and weighed in on what we're seeing and made suggestions, and just collaborated in scientists. It was a great trip to work together and try and make progress on something, but it's like, gosh, this is a lot of sand. And so we were near a date palm plantation, and as we went down maybe 6 or 8 feet, there was water that was seeping in, so that once they had got done with the backhoe, it wouldn't reach after a certain depth. So they lowered men down in the buckets, and they would dig down by hand, and they would take the buckets of sand out. And this is how they continued going deeper and deeper. So it was fairly laborious to do this. That you just have to overcome different things like that water seeping in. And so I didn't expect that there would be water that close to the surface. And I'm not sure if it was coming from the plantation because they irrigate that, but they also have hot springs, so So there's cold springs and hot springs that were mentioned about Atlantis. And so we went and saw one of these hot springs, and those come from much deeper. And they pump that water up because it's going to be less mineralized than the shallow water. And they pump it out onto kind of like a fountain with all these baffles. So, because they need to cool it because it's boiling hot. And then they have like a labyrinth that they funnel the water goes through to help further cool it. And then they can mix it with the cold water that's closer to the surface and use that. So it's like thing, you know. So it would be good to like network with engineers over there and petroleum people who have well logs. And have you ever found like an artifact as you're digging? And, you know, have you come across anything like that? Because before they like look for petroleum or water or whatever, if they're going to drill a well, they're going to want to like bore down and, you know, whatever they bring up, you know, they're going to annotate like, oh, it's sand so far, and then there was a clay layer, and then there was silt, and then, you know, they're going to record all that, and that could be very helpful to us archaeological minded researchers. But I just don't know. And they speak.
Yeah.
Right. You know, somebody may already know something. We just got to network with them, but they speak French and Arabic over there. So that's a bit of a handicap for English speaking people. You know, so there were there were some archaeologists in the group that could speak English, that native Tunisians speak English. So I've tried to appeal to them. Can you like net with petroleum engineers, see if you can find anything out? Which they may not share their information because they paid money to drill those cores, and you know, why should they share that where a competitor could put that to use, you know, rather than, well, you know, we're scientists that want to find Atlantis, you know, other cultures. Right. So I don't know.
The trick's got to be
befriend
Yes, befriending. The trick has got to be finding some friends in there, because you just opened an entire rabbit hole in my mind of realizing that big oil is sitting on probably a lot of hidden archaeological discoveries that are just in the stacks and reams and gigabytes of survey data that it was just like, well, that's noise, there's no oil there, so we're not going to look there. They filtered it out. So behind the layers of trade secrets and all that stuff, there's a lot of data someone needs to get into and then look at it.
Right. And I mentioned in that presentation at Cosmic Summit that there is a Roman town that got buried for like 1,000 years. You know, it was established, I think, by Emperor Hadrian, maybe. And then it was abandoned or whatever, and it got buried by the sand. And then later somebody found it and they excavated, and it's like, gosh, you know, the whole town was hidden for 1,000 years. So that's just the power of sand hiding things, and, you know, then maybe exposing them later, or somebody sees something sticking up out of the sand and it's like, oh, what's that? And they find there's a whole city underneath there. I wish there was an easier way to like look underneath the sand and see what's down there. You know, we have ground penetrating radar, but it's not going to go down 60 feet, you know?
Yep. Well, I wasn't planning on doing a whole SAR discussion. Obviously, the synthetic aperture radar was another big feature, big news in the scientific community this summer. We don't have to go all the way down there today. But there's a lot of places that we want to scan with SAR for sure.
Well, there was some archaeologist that was using satellite data to look underneath the ground. And so I thought, I don't know, if we could use that method, maybe that would help. I just don't know how deep that works. Maybe I think it was like jungle sites, but also desert sites she was looking at, but they probably weren't buried that deeply.
Mm-hmm. That's a good point. They've had good success with LiDAR getting through canopy tree growth. I don't know how far LiDAR would go with sand, though. Probably not very far.
Probably not.
Winding things down, I wanted to ask about one contemporary subject, so we can maybe get a clip and talk about it, because we talked with everybody about the 3I Atlas comet. There's an interstellar object. It's in the solar system. What have you heard? What do you think? Do you have anything to pour into the pot here while we stir it up on 3i Atlas?
No, not a whole lot. I did see on Redacted that there was a story that I think it's the U.S. There's some concerted effort up some kind of a shield or something because they're afraid it's an alien. We don't know their intentions and whatnot. So, and the pictures I've seen of it, I don't know if it's like AI generated, but they make it look like it's a ship. And so apparently Avi Loeb is the one who's done a lot of research on it. And he said it's on the other side of the sun, but when it comes back, it could trigger some solar flare or something that could be detrimental, to the Earth, such things like the Carrington event. So that's about all I know about the 3i Atlas. So
that's about as much.
What do you know about it?
That's all. That's about all we all know. It's the hype level that's different depending on what source you look at. The hype is either way up or way down. So it's here. It's with us. We're taking a look at it.
Right.
It doesn't sound like Planet Nibiru coming back with Zach Sitchin flying at the helm. I think we can roll that out at this point.
Right. And when is it supposed to get close to Earth? Like, is it a year or less than a year?
I think within a month.
I don't know.
Sorry, go ahead, Rick. Yeah.
Beginning of December is when it's supposed to be the closest for us to be able to see, is what I've heard.
So just a month or so. Well, we'll find out soon enough, won't we?
It's getting close. Well, we've really enjoyed this chat with you today, Joanne. Sorry I wasn't better prepared, but we had fun. We're into all this stuff. So,
right. Well, thank you for having me. This has been interesting for me too, to relive all of those the field work back then. So,
last thing, where can people find your work? We'll put a link to your ResearchGate in the description of this video. What else would you like to show off?
There's the link to the Cosmic Summit. Depending, you can go back and maybe see the talk. So my first time, the Cosmic Summit has been running for 3 years so far. And George Howard organizes that, has a great team of scientists that come in and give very interesting talks about all kinds of things related to ancient history, ancient mysteries, and so on. And so my first time there, he had me come up on stage to answer questions about the Younger Dryas and the Black Mats. Younger Dryas onset and the Black Mat with him and Mark Young. That was a great experience. Then the second year I was there, I talked about how we detect fire in the geologic record, in the sediments. Not just sediments, but trees, tree rings, parse in archaeology, where is the fire in general, and then showing how we collect and that kind of thing. And then, as you know, this most recent June of this year, because I had been on this expedition this year, it's like, well, I talk about, which is Atlantis in the Sahara. Who would have expected? I mean, what a great place for Poseidon and Zeus to hide Atlantis. Underneath the desert. If it was an aquatic city, I think to look in the desert to find an aquatic city. So, as I compiled information defending the position, because some people think it's off the coast of Spain, it's close to the Straits of Gibraltar, but it could be that there's more than one Gibraltar, and more set of pillars of Hercules, and so it leaves it open to other places than just Spain. So
yes,
it's just an intriguing concept to think that it's an aquatic city and you wouldn't think it would be in the desert. But if Zeus and Poseidon had it with all the descendants of Poseidon, they have become so bad. I've just felt like it's my responsibility. I have to take care of them. I have to remove this problem. And so he's the god of the sea, as well as the god of earthquakes, as well as the god of horses. So it was destroyed in an earthquake, and then it was inundated with water. So that sounds like Poseidon took care of the problem. Cosmic Summit and ResearchGate, and then I've sent you the links if people want to look at my dissertations. That's fairly dry, but there's graphs and pictures and maps and stuff in there that people could skim through that and maybe read the abstracts and the conclusions and get some idea of what's going on with the research I did on those lakes.
We are going to link all of those things in the description of this video. It may be dry, but it's not every day that we get to feature a PhD dissertation on our channel. So we're proud to do so, and you should be proud of your hard work. So we appreciate that.
All right. Thank you. Thank you very much.